Welcome to the Changing Landforms Unit Internalization video. My name once again is Sean Tamarisk of KIPP, Massachusetts. The big question for this unit is why is land shaped the way that it is and how does it change? Great, so the unit starts out lesson 1 with the overarching phenomena of the Oceanside Recreation Center, an idyllic nature, wildlife, and summer camp located on these sea cliffs here. But the director of the camp has a puzzle for our students. He's hired them as geologists to investigate a question he has. A long time ago, the flagpole for the center used to be about 2 meters from the edge of the cliff. Now it's only about 1 meter. Why could that be? Did the flagpole itself move? Did the cliff move? So buckle your seatbelts, you're in for quite a ride. Before we begin, make sure you did your pre-work in the unit plan shown here. This unit's all about the wonders of landforms, from rivers and deep canyons, to tall mountains and low valleys, to flat plains. And the first part of the unit is all about getting kids comfortable with the idea of landforms. This unit serves as their introduction to geology. It's typically the first time that kids are learning about land and rocks and Earth's features. So it serves as an important stepping stone to later topics such as the rock cycle. This unit includes some mystery and wonder. For example, students get to learn about the mysteries of humble sand. When it's magnified a few hundred times, turns out sand is actually made out of tiny bits of rock and sea creatures, such as coral, sea stars, and shellfish, all of which is evidence of erosion. Students learn about the idea that water always wins in the long term. It beats relentlessly on things like sea cliffs until they're ground into nothing but sand. And water will continue eroding and working away at human creations until millions of years after we're gone from this planet. The unit introduces students to longer scales of time, which will be important in understanding geology and evolution later on. By talking about processes that have taken tens, hundreds, or thousands of millions of years to complete. Deep time, such as shown here, spiraling back to the beginning of the planet. More practically, students learn about maps and how to read them. Since many of our students don't have social studies as a class, students' map skills are often lacking, an important skill in the modern world and for academics, social sciences. Towards the end of the unit, students learn about landslides and other natural disasters that have to do with erosion, and they learn about how engineers mitigate these through ingenious solutions. That brings us to big question number 1. First of all, what is the land made of itself, and can it change its shape? Does that explain why the flagpole appears to be moving? In this first lesson, students read the book Landform Postcards, which introduces them to landforms such as canyons, valleys, plains, and so forth, all the while trying to answer the question, what are all these landforms made out of? The answer is rock. In lesson 2, students read more in the Handbook of Land and Water, where they learn about other landforms such as islands. This is the reference text for the unit. In the third lesson, students actually look at samples of sand and start to determine that sand is actually made up of tiny bits of rock, tiny pieces of landforms. Students follow this up by reading Gary's Sand Journal, which tells them more about how to read the sand. For example, big grains of sand are evidence that there are big waves because big waves can carry big things, whereas small grains of sand are evidence of there only being small waves in an area. For example, many spots in the Pacific Northwest have beaches with really large rocks strewn about the beach instead of sand. This is evidence that the Pacific Northwest gets larger waves and larger storms than a fine sandy beach in the tropics. Students make observations of the sand and say what it could be evidence of. Next, students model how they think the sand came to be by shaking hard candy in a glass jar and noting that it breaks into smaller pieces the more you shake it. At this point, students should understand Progress Build 1. Landforms are made of rock and rock can change. Therefore, landforms can change. Students use this understanding to answer the puzzle of the cliff and the flagpole. Go ahead and complete this task yourself, then check back here. All right, for part A, you should have marked B. The cliff is made of rock. Rock can break, so pieces of the cliff must have broken off. And you should have completed the following sentence. Landforms are made of hard candy. Just kidding. Landforms are made of rock. Here's an exemplar response. Please read that over and check it against your own. And as you can see, this is assessing Progress Build 1, the idea that landforms are made of rock, rock can change, and therefore landforms can change. That's the foundation for the next 2 progress builds. On to big question number 2. And now that we know that the cliff has changed by breaking apart, we want to know how it changed. What made it break apart? So the big question is, how do landforms change over time? You see pictures of chalk here because students start this next lesson by pouring water in chalk and noticing that little bits of chalk break off into the water. They suggest that water may be a mechanism of erosion. In the following lesson, students read the book What's Stronger? How Water Causes Erosion, And every section of the text poses the question, what's stronger? Water versus this, or water versus that. Give an example. What's stronger, a river or a mountain? The answer is a river. Mountains may look big and stable, but over long, long periods of time, deep time, water breaks off pieces of rock from the mountain, carries it down, and the mountains become smaller and more rounded, and little by little erode even further. And ultimately, all mountains wash into the sea, eventually, to paraphrase Jimi Hendrix. Students then attempt to transfer their understanding to new contexts, such as natural rock arches that form, as well as canyons and valleys, to try and explain how these features were also caused by water eroding rock over time. Next, students return to the Handbook of Land and Water and learn how some changes happen slowly, such as mountains eroding, but other changes can actually happen very fast, such as in a landslide. They model this with sand and pebbles, pouring water over it and blowing on it to see how it causes the rock to erode. They also model this digitally with the simulation that shows changes over a shorter period of time and a longer period of time. At this point in the unit, students should understand Progress Build 2. Wind and water can cause landforms to change. When they hit it, they cause pieces to break off. Landforms can change very quickly, such as in a landslide, or very slowly through gradual erosion. All this leads up to Progress Build 2 focus task, the puzzle of the cliff and the flagpole, part 2. Now we're getting to the explanation of how did the cliff change over time. Please go ahead and complete this task and then check back here. So for part A, you should have marked A, that birds carried away rocks. No, actually. You should have marked B, that wind and water from the ocean and from storms hit the cliff again and again over many years, causing pieces of the cliff to break off. And for part B, you should have marked section A. The director should be worried because a landslide could eventually happen unexpectedly. There's an exemplar response at the bottom here. Please check that over and compare it to your own. As you can see, this assesses Progress Build 2, the idea that wind and water can cause landforms to change when they do this by causing pieces to break off. Landforms can change very quickly, such as a landslide, or very slowly through erosion. Take a look at this exemplar focus task. Here you've got a really nice example of a student labeling all their work, showing, for example, the wind, little pieces of rock breaking off and eroding, the flag, and the cliff. Nice. At the end of this big question are several optional lessons where students read the book Making Models of Streams to learn about how scientists actually use physical modeling to study erosion and other geological issues. All right, on to big question number 3. How do engineers study landforms and protect people from erosion? So this is where we first get into maps. And one of the first skills in being able to read a map is recognizing that a map is a bird's eye view of a place, a view looking down from above. Although this may seem easy and simple to us, for many students actually struggle to visualize what a place looks like on a map. So we work on this skill for this lesson. In the next lesson, we return to the Handbook of Land and Water and see more examples of maps, and in this case, look at map legends and keys to see different ways things like elevation are featured on a map. In the third lesson for this section, we make a mountain out of cotton balls, draw it from the side and then from the top to practice our map drawing skills. We then erode the mountain and draw it again to show how geologists use maps to show changes over time. We also practice mapping by mapping the classroom and learning about north, south, east, and west on a map. There's a funny little side standard about using information to find liquid water and frozen water on the Earth. So students can use Google Earth or online atlas or a physical map to look for water and learn more about reading map features. Next, students learn about landslides and other hazards from erosion and the different ways that engineers work to mitigate this, such as through retaining walls or pins, revegetation, and wire mesh. At this point in the unit, students should understand Progress Build 3. Geologists and engineers construct maps of landforms to better understand the landforms and how they change over time. They use a variety of methods to stop rock and sand from carrying away or burying buildings or parts of towns. All this leads up to Progress Build 3 focus task, saving the recreation center. Now that we've determined that landslides are a potential hazard for the recreation center, students' job is to design an engineering solution to help prevent a landslide. Go ahead and take a few minutes to complete this task and then check back here. Great, so here's my example, although yours may look a little different. In my case, I chose to go with a wire mesh solution to hold the rock in place. So you see I've drawn it right here on the cliff. And then I've drawn pins drilled into the rock to hold the mesh in place. Other solutions such as retaining walls or longer pins are perfectly fine as well, as long as students have a viable solution and a clear description of their solution. You can see my example right here. The other feature of this focus task is assessing how well students can identify a location on a map. So here we have the recreation center from the side view, and here we have it from a top-down view. Students' job is to simply mark the location of their landslide solution. In my case, I marked it with a black line right here because I believe this spot best corresponds to this picture right here. You can see the flagpole, the recreation center, and the side of the cliff right here. However, I'd also accept anywhere along this red line right here is valid, since these are all spots where a landslide could occur, and so students putting their engineering solution here would be fine as well, as long as they demonstrate the ability to notice this terrain difference on this map. At the end of the unit is an optional engineering task called Save the Rec Center. In it, students create a model of the recreation center on the cliff using sand and small plastic buildings. They then use materials such as popsicle sticks, rocks, and plastic to create a solution that prevents erosion. Finally, they pour water over it to see if their engineering solution prevents the sand from washing away. It requires the purchase of a little bit of extra materials, but it gives students the opportunity to create an engineering solution to a problem. All right, on to the end of unit assessment. This question assesses Progress Build 1. Go ahead and take a minute to complete it and then check back here for answers. Great, for canyon or valley, you could have marked any valleys here. This is a prominent one. You could have also marked this one, or even little ones in here all constitute valleys. Mountains, all of these are mountains over here, as well as over here. And finally, plains. These are pretty much plains over here, and plains over here. So the idea is students are able to identify basic landforms. This assesses Progress Build 1, shown here. For the end of the unit assessment question for Progress Build 2, here's an example, number 5. Please go ahead and complete this now and check back here. And here's what I've got. This would most likely have taken many years, and the hole in the rock got bigger because the water eroded the rock by breaking off small pieces, making the arch bigger over time. It's important that kids demonstrate that they understand how erosion works as small pieces of rock breaking off from water or wind hitting it. And the end of unit assessment question for Progress Build 3 has students looking at different engineering solutions to this problem of a hill right next to a house. Go ahead and complete the question and check back here. You should have marked the retaining wall with bushes planted. The reason why is the wall will hold the soil back and prevent it from sliding down, and the bushes and plants will also absorb rain, preventing the water from eroding the dirt. Fence would not hold back dirt. Dirt would just slip right through the fence. Same for a plastic fence or a wooden fence. And a windbreak made of trees, the trees would just be knocked down by a landslide, not able to hold back the dirt. All right, that ends our unit internalization video. Thank you very much for taking the time to be as prepared as possible for your students. For KIPP teachers, and I recommend this for everyone else as well, go ahead and complete these additional steps to be as prepared as possible to teach this unit. Thanks.